Students, today I am going to teach about organ plane and polar representation. The first is organ plane, the plane having a complex number assigned to each of its point is called the complex plane or organ plane. To make understand you, I am taking some complex number. The first is 2 plus 4i. 2 is the real part and 4 is the imaginary part. So the point will be 2 and 4. This point can be assigned in this plane, so this plane is called the organ plane. See, these complex numbers, let us try to assign their point on this plane. The first complex number is 2 plus 4i, but you must remember the x-axis is horizontal, is the real axis, will represent the real part values, and the y-axis is vertical, is called the imaginary axis. The imaginary values will be represented here. So in this complex number 2 plus 4i, the point will be 2 and 4. We will try to assign on this plane. We know that 2 is positive, so we will move positive part of x-axis. We will move 2 points on x-axis 1, 2, and on along y-axis we will move 4 points on the positive part of y-axis 1, 2, 3, 4, and getting this point A with the coordinate 2 and 4. Like that, minus 2 plus 3i, this also we can assign the point on this plane. We have to move minus 2 points, minus 1, minus 2, and plus 3 points on y-axis 1, 2, 3, and getting the point B with the coordinate minus 2 and 3. But you must remember, in this complex number the value of x is positive and the value of y also positive, so it lies in first quadrant. And in second complex number the value of x is minus and value of y is plus, so it lies in second quadrant. Then in this complex number x is negative, y also negative, it lies in third quadrant, and when we assign the points, point will be minus 5 and minus 2. We will move minus 5 points on x-axis and minus 2 points on y-axis, and getting this point C. Like that we can assign this point also. But you must remember what is the sign of x is positive and y is negative, so it lies in fourth quadrant. And this point 0 plus 1i, in this complex number there is no real values, real part value, and only imaginary part. So when we plot the points of 0 and 1, x is 0 not moving and y is 1, we have to move plus 1 on y-axis and getting this point. So if real part is 0, it will lie on y-axis, and this also imaginary part is 0, getting only real part, so it will lie in x-axis. The point is 2 and 0. We will move plus 2.1, 2, and no value of y. Y is not moving, so it lies on the x-axis. Now polar form of a representation. Polar representation of a complex number. This topic is important. See, any complex number can be represented ax plus iy or a plus ib. This form is the rectangular coordinate form. How to write polar form of a complex number? Any complex number can be expressed in terms of r and theta. R cos theta plus I r sin theta. This is the polar form. The value of r is the modulus. Modulus, what is the formula of modulus? We know that under the root of square of the real part and square of the plus square of the imaginary part. How we get this value of r and cos and sin? I will show you here. In place of x we write x cos theta, in place of y we write r cos sin theta. How it comes I will explain here. So in this what is common? R is common, taking out r common and getting this value. and this angle is called the argument. This formula will be given by tan inverse y by x, or tan theta equal to 10 equal to y by x. That one I will explain here. See, let us assign the point x and y on this plane. So we have to move x point along x axis and y point along y axis, then getting this point P with the coordinate x and y. When we join O and P, this is the distance from the origin to the point P, and represent that distance is r. We know that below r is under root of x square plus y square. After joining this, we get one diagonal triangle with the angle theta. Then O to Q is x. How much distance? X. Q to P is y. We can apply Pythagoras theorem, because this is the right angle triangle. By Pythagoras theorem, hypotenuse square equal to sum of the remaining two sides square. And what is hypotenuse? R square. The remaining two sides square is x square plus y square. When we find out the value of r, getting under root of x square plus y square, and like that getting the value of r. Then by using trigonometric ratio, we are going to get the value of x and y. Y is the perpendicular and x is the base. So we can apply the trigonometric ratio sin theta equal to perpendicular by hypotenuse. What is perpendicular? Y. What is hypotenuse? R. Y by r. When we try to find out the value of y, doing cross multiplication, r sin theta, and then cos theta equal to base by hypotenuse. Base is x, hypotenuse is r. When we find out the value of x, getting r cos theta. So in place of x we write r cos theta. In place of y we write r sin theta. When we find out the angle argument, say tan theta equal to sin theta by cos theta. Tan theta equal to, what is value of sin theta? When we find out value of sin, y will divided by r, y by r. When we find out the value of cos, x by r, replacing their values and making cancel r and getting y by x, and theta equal to tan inverse y by x. When we find out values, all this time we can use this formula. So tan theta equal to y by x, or theta equal to tan inverse y by x. See, when we find out the angles, we need to know this figure. Any given complex number, it lies in first quadrant, their sign will be plus and plus. Real part is plus and imaginary part also plus. Second quadrant is this. I think you understand these things. Then if the angle lies in the first quadrant, when we find out the argument, we will take only the getting angle theta, acute angle. If according to this sign, if the given quadratic equation complex number lies in second quadrant, when we find out the argument, we will use this formula, argument equal to pi minus theta. If it lies in third quadrant, when we find out the argument, theta equal to theta minus pi, or by just taking out the minus common, minus pi minus theta. If the angle lies in the fourth quadrant, theta equal to minus theta. We will use this formula. So angle in terms of pi, this also any given angle can be expressed in terms of pi. Some angles we have learned in class 10, 30 degree, 45 degree, 60 degree and 90 degree. How we can express in terms of pi? Pi equal to 180 degree, that's one we know. And how to write 90 degree in terms of pi? Pi by 2. 60 degree in terms of pi? Pi by 3. 45 in terms of pi? Pi by 4. 30 degree in terms of pi by 6, and 360 degree in terms of pi 2 pi. Exercise 5.2, the first one is z equal to -1 minus I root over 3. In this question we are going to find out the final modulus and argument. Modulus, what is the formula of the modulus? R equal to under root of x square plus y square. Next argument is the theta. This question number 1 I also have done. You try this question number 2. See, from the question number 1, the real part x is -1 and imaginary part is minus root over 3. Let us find out the modulus. Modulus is represented by r, so r equal to under root of x square plus y square. The value of x is -1 holding square plus below y is minus root over 3 holding square, and getting this value 2. Then let us find out the argument. Before finding out argument, we have to use this formula tan theta equal, before I said to you, tan theta equal to y by x. Tan theta is equal to what is value of y? Minus root over 3 by -1. After making cancel, getting root over 3. This is in terms of tan, this is a number only. So this number we must try to express in terms of tan. In the class 10 we had learned that tan 60 degree equal to root over 3. In place of root over 3 we can write tan 60 degree, tan cancel, and value of theta is 60. Now this 60 degree we have to express in terms of pi. I already explained to you 60 degree in terms of pi is pi by 3. Now once again you must remember the value of x is negative, the value of y is negative. Convert each of the complex number given in exercise 3 to 8 in the polar form. This type of question will come in the exam getting 3 marks. Question number 3. 1 plus minus I. The value of x is 1 and value of y is -1. When we find out value of a modulus, we use this formula and getting root over 2. Then we need to find out the argument. Same process we have to follow. Tan theta equal to y by x, tan theta equal to -1 by 1, getting -1. We will not count the minus sign. See, this 1 can be expressed in terms of tan 45 is 1, so tan theta equal to tan 45 degree. Tan cancel and theta is how much? Pi by 45 we can write as pi by 4. Value of theta is pi by 4. Then we have to check this complex number lies in which quadrant. X is positive and y is negative. So if x is positive and y is negative, it lies in 4th quadrant. What is the formula? When we find out the argument, we have to use minus theta. Minus, what is value of theta? Pi by 4. Now we get the value of r and theta. So therefore the polar form of any complex number is z equal to r cos theta plus I sin theta. So what is value of r? Root over 2. Replacing their value cos, what is value of pi? Minus pi by 4. Sin, what is value of theta? Minus pi by 4. Question number 4. And z equal to -1 plus I. The value of x is -1, the value of y is +1. We will find out the value of the modulus r equal to, then getting this value. Then we need to find out the theta. Tan theta equal to y by x. Tan theta equal to, what is value of y is 1 and value of x is -1. Same before what I told. Tan theta equal to tan 45 degree and getting value of theta is pi by 4. But we have to check The given complex number lies in which quadrant? X is negative and y is positive. It lies in second quadrant. So as x is negative and y is positive, so theta lies in second quadrant. So when we find out the argument, we have to use this formula, pi minus theta. What is value over theta? Pi by 4. After subtraction we get 3 pi by 4. Now we get the value of r and theta. So how to write polar form? Polar form of any complex number is r cos theta plus I sin theta. So what is value of r? Value of 2 cos, value of theta is 3 pi by 4, I sin theta. What is value of theta? 3 pi by 4. Question number 6, minus 3. There is no imaginary part, only real part. So this minus 3 can be right again, minus 3 plus 0i. Before I explain to you, if the imaginary part is 0, it will lie in x-axis because only getting only real part. The value of x is minus 3 and value of y is 0. When we find out the modulus, x equal to minus 3 whole square plus value of y is 0, 0 square equal to, getting the value is 3. Getting the value of modulus, and we need to find out the angle again, tan theta equal to y by x. Then what is value of y? Y is 0 and the value of x is minus 3. The value it comes 0. But we know that this given complex number is not lying in the first quadrant, second quadrant, third quadrant and fourth quadrant. It lies on the x-axis. So we know that tan 180 degree is 0. The value of, in place of 0, we can write tan 180 degree. The value of tan 180 degree is 0. So tan cancel. What is value of 180 degree in terms of pi is pi. So tan theta equal to pi. We will not use any formula since this given complex number is not lying in any quadrant. So getting this value will be the argument. So argument equal to pi. The polar form of z is r cos theta plus I sin theta. The value of r is 3, theta is pi, sin plus I. In place of theta we can write pi. Quadratic equation. Any equation of the form ax square plus bx plus c equal to 0 is the quadratic equation. A, b, c are the real numbers, but the coefficient of x square does not equal to 0. Then for every quadratic equation, they have two roots. One is alpha and one is beta. We had learned in class 10. So that alpha beta can be derived from this formula, x equal to minus b plus minus under root of b square plus b square minus 4ac divided by 2a. B square minus 4ac, this value is called the discriminant. So discriminant is equal to b square minus 4ac. According to this value, we can say 3 points. It can give 3 points. This value is greater than from 0. Then the two roots are real and distinct. If this value becomes 0, the roots are real and equal. If this value becomes minus, that means less than from 0, no roots. From this value, it becomes minus, we get the complex number. See, exercise 5.3, solve each of the following equation. The given equation is x square plus 3 equal to 0. X square, the general formula of a complex number is ax square plus bx plus c equal to 0. In this example, in this question, getting only x square, there is no bx part. So we can write as x square plus 3 equal to 0, as x square plus 0x plus 3 equal to 0. Comparing with the general form of a quadratic equation, the value of a is 1, b is 0, c equal to 3. Then we find out the value of discriminant, getting minus 12. So let us find out the solution of the given quadratic equation. X equal to this formula we have to use, and replacing the corresponding values. B equal to 0, this value becomes minus 12. So this minus 12 can be write as a minus 1 into 12. So the value of minus 1 is I square. In the last explanation I already give the formula. Minus 1 equal to I square into 4 3s are 12. In place of 4 we can write 2 square into 3, and those with the power 2 then can make cancel with the root over. So I and 2 is coming out, and only 3 is left under root of 3. Under the root of 3, 2 is cancelled, then plus minus root over 3.